Okay, Assalamu alaikum. Today we'll be going over 12.2, which is structure charts. So basically, let's go over what a structure chart is to begin with. So it is a modeling tool used in program design to decompose of a problem into a subset task of problems, right? A structure chart shows a hierarchy or a structure of different modules and how they connect and interact with one another. So let's talk about how we can represent, how we can draw structure charts, right? So a basic structure chart is shown here, right, which converts the temperature from Fahrenheit to Celsius, right? So you have this hierarchy model. So convert temperature is at the top of the hierarchy, and then you have input temperature from which a variable is being taken as input, which is known as temp. Then that variable is being passed on to convert to Celsius module, right? And then when it's being converted, the temperature is being then passed back to this convert temperature, and then it's being passed forward to temperature to output temperature. So this is basically a hierarchy and a subset of modules on how a bigger module, the convert temperature, works, right? Okay, so now we'll go over the same structure chart with an extended amount. We have extended it to deal with both Fahrenheit to Celsius and Celsius to Fahrenheit conversion, right? So previously, when what you saw on the last slide, you only saw this bit of the structure chart, right? So now we've extended it to check whether the inputted temperature is in Fahrenheit or not. So if it's in Fahrenheit, then we'll change it into Celsius, right? And if it's not in Fahrenheit, that means it's in Celsius, and then you'll change it back to Fahrenheit. So basically, you can see how this module works. So you first take the temperature as input, right? Here you take the temperature as input, then you send the temperature down to this convert module, and in the convert module it first checks if the temperature is in Fahrenheit or not, and then it proceeds with whatever module that is to be proceeded with. Then it returns back the temperature variable after the conversion, and then that conversion is sent to the output temperature table, where you are sending the temperature which has been converted to be outputted, right? So this is basically how a structure chart basically models all your sub modules and shows a hierarchy on how a big module is basically working, right? So now we have a question here, right? So the question basically states that you need to create a structure chart to input the radius of a sphere and then calculate and output either the volume or the surface area. So the algorithm also should repeat until a radius of 0 is entered. So before we begin with this, so we'll need to highlight what we are doing. So basically we'll start by making this structure chart, right? So our top of the line would be volume or surface, oh sorry, volume and surface area calculator. Okay, so basically this is our topmost hierarchy module, right? And then whatever happens will happen inside of it, right? So first of all, we're going to take the radius as input, right? So input radius, this is going to be connected, and the radius variable is going to be sent to the module, right? And after that, oh sorry, I'm drawing an arrow, my bad. Okay, so here we'll have the calculate module, right? So a calculate module, so first of all you'll need to see what the user presents you with, right? So you'll see if you have to calculate the volume or not. You can have surface area here, I am having volume here. So if you will need to calculate the volume, then you'll just move over to the calculate volume part of the structure chart. And if you don't need to calculate the volume, right, so then you'll have the calculate surface area structure chart, surface area, right? So this is basically, we're laying out the basis of how this program is going to work, right? Okay, so now what we need to understand over here is that if it's a volume, so then you'll be passing in the radius, right? So the radius will be passed, and then you'll be passing back the answer to it. And so does happen here. So the radius will be sent as an input, and the answer will be sent as an output, right? So here we have the answer, right? Okay, so what you need to know is that the question asks us that we should repeat it until a radius of 0 is entered. So to show repetition, right, to show repetition we do this, right, and we have our radius here. Okay, so we showed it this way. So this basically this basically yellow line which is going back inside shows the repetition, and then we lay down the condition for the repetition until radius entered equals to 0, right? And the last part after that. So from here we'll be getting our answer, right? So what do we do with that answer? So we need to pass the answer on to our output answer module, right? So basically this is how a structure chart is constructed, and we also went over how a repetition takes place. So this yellow highlighted area is how a repetition takes place, and here is our condition for the repetition, right? So this is our condition for the repetition, right? So this is all you need to know about structure charts. So now we move on to state transition diagrams, right? So what is a state transition diagram? So first of all, we need to have a background of what a finite state machine is. So basically, it is a model of a machine that can be in one of any fixed possible states. So you'll have possible states, and it can be in either one of those states. It cannot have another state apart from what is defined for it, right? So changing from one state to another state is known as a state transition, right? So take for example, a basic thing is changing from 1 to 0 is known as a state transition, and 0 to 1 is also known as a state transition, because you're changing what is already been defined, right? So that is basically a general example of what a state transition is. Okay, so a diagram which shows the behavior of a finite state machine is known as a state transition diagram. So you have this mathematical model, and when it changes its possible states, to show that we use a state transition diagram, right? So a state transition diagram can be constructed as follows, right? So the states are represented as nodes or circles. Transitions are represented as intersecting arrows. Events are represented as label on those arrows, and conditions can be specified in square brackets after the event label. The initial state is always represented by an arrow with a black dot. A stop state is indicated by a double circle, right? So this is basically an overview of how state transition diagrams can be constructed, right? So this is basically an overview, right? So now we'll go over and look on how a problem can be solved using the state transition, right? So here we come to this new problem where states are defined within events, and the next states are also defined. So we'll go over what this is. We'll read this theory for this. So it says, if the button is pressed on standby if a button is pressed once in standby or off, the TV switches on. If the button is pressed once when TV is on, the TV goes to standby. If the button is pressed twice when the TV is on, it goes to off. Double presses in standby or off are ignored, right? So we need to make the state transition diagram for this, and we know by ourselves of how we can do that, right? We can basically make a state transition diagram right here. So let's go over on how we can do that, right? So we'll have off, which is one of our states, and it's going to be in a circle, right? We're going to have on, it's another one of our states, and we have another state which is known as standby. So these are the three states we have right now, right? Okay, so first of all, let's go over if the button is pressed once in standby or off, the TV switches on, right? So we'll have this arrow, right? And we're going to label this single press, right? And we have this arrow, and we're going to label this single press as well, because when you single press from an off state or a standby state, the TV switches on, right? Okay, so now we need to know about what happens. Let's read over what happens next. If the button is pressed one when the TV is on, the TV goes to standby, right? So here we have an arrow, and this happens when a single press is done. So single press. The TV, if the button is pressed twice when the TV is on, it goes to off, right? So this happens when you have a double press, right? Okay. Double press in standby or off are ignored. So basically this means that when you double press on off, you go back to off. You don't do anything else. So this is known as a double press. And when you do it on standby as well, you stay in standby. So what you need to be aware about, since the question is very vague about what our final state is, so we can assume in this manner that a final state is an off state, right? Because that's how mostly TVs or refrigerators or any kind of a normal state machine ends up. So basically that's where your end state is, that it's turned off. So in this case, we'll assume that the off state is our final state, and that is why we are representing it with a double circle indicating that it is the final state, right? So here is your overview of 12.2, which is structured charts and state transition diagrams. Thank you for watching.